Hi guys, welcome back to my channel Programming with Pirai. In today's video, we are going to see about what is a quick sort. Okay, if I give you an array like this, okay, and you want to sort this array like this, then we can use one of the sorting technique called quick sort. Okay, what this signifies? In quick sort, we use an algorithm called quick select plus a recursion. Okay, first of all, what is quick select? Quick select is something like we will take each and every elements. We will take each and every elements and place them in the correct position. Okay, I will place them in the correct position. By doing that in each and every elements, I will be ending up in what? In a sorted order. Okay, what it signifies? It signifies, right? If this is a given error, then I will place this 5 in this position. I will place this 2 in this position, then 1 at this position, and 3 at this position, 7 and 8 at the correct position. So you may ask how we can place them in the correct position. Is there is any trick? Yes. So see here. So we will take a pivot element. So what is pivot? Pivot is something that element should be placed at the correct position. Okay. So pivot can be of our choice. Either it can be start, end, mid, or random. Anything. Can take anything. Now we want to repeat this process for the left and right. Okay, what it signifies? Okay, let us understand this. First of all, what is the array value? It is 1. So 8, 1, 7, 3, 2, 5. Okay, now initially I will take this as our pivot. I will take the pivot as what? The end. Okay, now where should I place this 5 such that the 5, its left should be what? Less than the 5 and right should be what? Greater than the 5. You may ask why it is left should be less than and right should be greater than. Because see here in a sorted order, what is the left elements of this 5? It is less than. What's the right element of this 5? It is greater than. Can you understand this? Okay. So I can say I will place the 5, but before that I will place all the small elements. So it will be 1, 3, 2, and I will place the 5, then 8, 7. So this is the initial step of placing the 5, right? So now 5 is what? 5 is at that correct position. Now we want to worry about what? Worry about this and this. Okay, now what should we do? We should do this step for this right and left too. Can you understand this? Okay, let us understand by taking this left subarray. Now it is the array, right? Now, if I take this 2 as our pivot, where should I place this 2? I can say this 2 should be placed at this point, right? At this point, this 2 is at the correct position, while this 3 is at the greater value of 2, so it is in the right, and this 1 is a lesser value of this 2, and it is in the left. Okay. Now my array something looks like 1, 2, 3, 5, 8, 7. Yes, that again doing this individually for this 1 and this 3. But see here, it is what? It is so much small. The value is what? So much small. What is it? What is the size? Size is equal to 1. So at this point, I can say it is in a correct order itself. It is in a correct order itself. See here, 1 is at the correct order and 3 is at the correct order. So leave it. Okay, now, what is our next one? Taking the right subarray. So right subarray is 8 and 7. Now in this, I will select this 7 as our pivot. Yes. Now, what should I do now? I should place this 7 where? At this first point, and here comes 8. Now, what is 7's left? There is nothing. What is 7's right? It is only 8. So I can say it is 7 and 8 is placed in the correct order. So my array something looks like this. Now, finally I got a sorted array. Yes. So what are the steps here then? We are just taking each and every end as a pivot at each and every recursion call and placing them at the correct position. Yes. Then after that, we are taking the left part and right part and doing the same thing that is done in before. That's why I'm saying that it is a recursion. It's a recursion. We are just sending the left to the recursion and right to the recursion part. Okay. Before going to this, how we can choose an element that place at a position such that its left elements are lesser than that and right elements are greater than that. Okay. It is called what? Partition algorithm. It is called what? A partition algorithm. For this partition algorithm, we can do in two methods. I will do in 2 minutes and also in write the code also. Okay. The first method is such that just take the same example 1, 8, then 7, then 3, 2, 5. Now, initially, I will take this as our pivot, right? Pivot. And I will take this as our end value. And this is our start value. We may confuse why it is end and start. But we are just took the subarray. No. But in real time, we don't take the subarray. Instead of that, we will take only the indices. Only the indices. Like, see here, I placed the element 5 here. The element 5 here. Okay. So I can say the left path will be where? From index 0 to index 3. And the right part will be from 3 to 4, right? So I only want this indices instead of that subarray. That's why I'm just using the indices. Okay, that's the start and end. And now my core logic is that whatever elements comes at first should be lesser than the pivot, and whatever element that comes at the last should be greater than the pivot, right? But see here, it is what? It is 8 and it is 2. So I can say it is a contradiction. It is what? Greater than 5. It is what? Less than 5. So I just swap it. By swapping it, what we can achieve? We can achieve the correct order. Okay, swap it. And move our start pointer here, our end pointer here. Yes. Now again. Whether our start pointer is less than 5, yes. So move here. Now, whether our start pointer is less than 5, no. So it is in a wrong position. Okay, now, whether our end pointer is at the correct position, that we can check it. So 3 is less than 5, yes. So it is a wrong position. We want a higher value, but it is a lower value. Just swap it. If I swap it, it becomes what? 7, and it becomes 3. And here comes end, and here comes start. Now see here, start exceeding the head. End. So it will be what? 2, 1, 3, 7, 8, 5. So this is the array. Now, see here, where is my start pointer? Start pointer is here, and my end pointer is here. I can say, from the start pointer, it is what? It is a greater value. And before the start pointer, are what? Smaller value. So I can say, just swap this as 5 and swap this as 7. Let's swap the start and the pivot. Now, my array something looks like 2, 1, 3, 5, 8, 7. Can you understand this? Yes. So, we successfully inserted our 5 in between, where its right side will be greater and its left side will be smaller. Hope you understand this. Okay. Now, let us understand this code. How to code it? Just see here, first of all, we are taking the pivot element as what? The end. Okay. Let us take the pivot element as the end. What is the next step we are just taking? We are just taking the 2 pointers. What is it? Start and the end. Okay. What is the start? I can say my start will be at see here, my start will be at this point. At this very start, right? So let us take this point as our start and this point as our end, so that it will be won't confuse us. Okay. So let me take this and take I and j. Let's take I and j. So I comma j is equal to what? Start comma end. Okay, because in recursion call we are just passing the indices, right? Let be the indices be start and end. Okay. So it will be end minus such that it will be pointing here, right? It will be pointing here. Fine. Now, what are the steps I require? I require this up to where? Up to my I is less than or equal to j. Can you understand this? While my start is less than or equal to end, I will proceed with this approach. Okay. Now, if my before value is, that is the starting values is less than my pivot, what should I do? I just continue. If my end value is greater than the pivot, what should I do? I just continue. Else it is not in these cases, then what should I do? Just swap my I value and j value. Simple. Right? Okay. After executing this code loop, what should I do? I just take the start pointer and swap with the pivot. Okay. So swap my I with what? Pivot. That's it. Yes. Can you understand this? Okay. And then return my pivot in this. Pivot in this will be what? I will tell you why we are returning. Here why we are returning this I. Okay. So this is the whole code for this above partition algorithm. Okay. let us understand another partition algorithm in which, see here, I'll take the same example, 8, 1, 7, 3, 2, 5. Okay, this is an carefully. I replace a I pointer here and I replace a j pointer here. Okay, and this is our pivot. Okay, now whether the first element is greater than 5, yes. Okay, don't do anything. Just take our j pointer and go here. Okay, fine. Now, whether this 1 is greater than this 5, no. So it means we should update first of all. So just make this as 8 and make this as 1. And update our I pointer here. And update our j pointer here. Can you understand this? Now, whether this 7 is less than this 5, no. Right here. Whether this 3 is less than this 5, yes. This means what? Just swap it. Swap this 3 as well. 3 is 8. Because I pointer is pointing to 8. And make this as what? Make this 3. And move here. Can you understand this? So here, this I pointer is what? This I pointer is a starting of the greater values. And this j pointer is a running value. Now, whether this 2 is less than this 5, yes. So swap this as what? 7. And make this 7 as what? 2. And swap this was I. And go to the j. J is here. So terminator. Loop is terminator. Now, what is my array? It is 1, 3, 2, 8, 7. And at last it is 5. Okay. Now what should I do? I should swap with my I pointer. So I pointer is here and pivot is here, right? So just take it. Here comes 5, here comes 8. So swap it. Can you understand this? At last we are swapping with what? I pointer. Can you understand this? We can also take this as j pointer, as this I pointer. Whatever you like, you can take. Okay, let us write the code for this. Initially, what we are doing here, we are just taking the pivot as what? The last element. The pivot is equal to ARR of end value. Next thing, we are just iterating one by one, right? For this j, for j in range on. For how many times? From this start to this end. So start, end. Go to up to the end. Okay. In next thing, what's rating? I should do right. I should check whether the current value. So ARR of j is less than the pivot. Or equal. Less than or equal to. Here also this put less than or equal. Here also put less than or equal. I forgot to put equal to because they are very duplicate. Right? Now, if this is the case, then what should I do? I just swap my I and j percents and do what? And do I plus. That's it. So I increment by I by 1. That's it. The code. Now at last, what should I do? I just swap my I pointer and the pivot. That's it. That's what I done here, right? I just swap my I and the pivot at last. Okay. And then return I. Because I is the position of the pivot. So this is the whole code for the second approach. You understand this? Both approach is same. We are using a 2 pointer. But for this approach, we use a forward pointer technique. And for this approach, we use one towards pointer technique. That's it. Apart from that, there is no that thing upon the time complexity, space complexity, anything. But you want to know, we can do this in the any one of the step. Okay. Now we completed what? The partition. Now we completed this quick select and this pivot. Okay. Now we want to repeat this again and again, right? So how to repeat this? Okay. To repeat this, I already told you what we are going to do. We are going to do a recursion. Okay. Step, quick sort. What we are going to do? We are going to pass what? Auxiliary array. S, which is the reference of this given array. Fine. Now, what's the next thing? Next thing, we want a start. Then we want an end. Yes, initially start will be 0 and the end will be 1. What is the index? 0, 1, 2, 3, 4, 5. So 5. It will be 0 and 5 initially. Okay. Now, what should I do first? I should do like take the partition. Do a partition and take the current value. If take for example this 7, 3, 2, 5, right? Now I can say that this 5 should be placed back. This 5 should be placed something like 1, 3, 2 and 5, then 8, then 7, right? So this should be placed here, and I want to call a recursion call for this and this separately, right? So I want to find what is a position, right? So to find a position, just call the partition function. Let's call the partition function for what? For this start and end. Just call it. So now either one of this function is called. Whatever as your choice, either one of this function is called, and this position is written. Now you can understand why this position is written, right? Why I'm returning there this I, and why I'm returning there as I. Can you understand this? This is the partition element option. Okay. Now what should I do? Okay. After finding this, I want to take this, right? So this should be like this is start. So up to start to p minus 1, it is one recursion call. And from p plus 1 to end is another recursion call. Can you understand this? Yes. So what's my first recursion call? It is quick sort, or take the reference as it is start, comma p minus 1, and take the quick sort, just take the reference and start will be p plus 1, and it will be end. Hope you understand this. Okay. How many times I want to do this? It goes on the infinity, right? So we need a base case. So what should be the base case? If you understand this clearly, see here, after my start exceed my end, or it is equal to my end, then I should stop here, right? I should stop here. So just put here, if my start is less than end, do this stuff, else don't do it. It will return to the above recursion, right? You can use this, or you can use another statement like if start is greater than or equal to end, then just return. So you can use either one of this. And understand this? Yes. So this is whole quicksort. This is the recursion call, and this is the partition function. Hope you understand this. Now let us analyze what is the time and space from t. So tell me what is the time of t. It is going to be over n log n at the best and average case, and in worst case it goes to n square. And what's my space of t? It is over a log n in a best and average case, and over n for a worst case. So this is the time and space of t. You may ask, why it goes to n square? Why it goes to n square? Because see here, if an array is already sorted or sorted in a reverse order. Just take for example, if this is the array. Okay. If I take this as a pivot, nothing changes. It is placed as it is. Okay. Fine. Now what is our left elements? Left elements are like this. Now again, from this, I will take this as a pivot, nothing changes. Again, this will be a left element. Again, I will take this as a pivot element, nothing changes. Take this as a left elements, and this is a pivot element. Again. So at the most, I run for what? N times. Can you understand this? So it is running for n times, as well as the partition function takes how much time comes t. It is also n. N for partition function. Partition function takes n complexity. Okay, and also this recursion goes to what? This recursion goes to n at the worst case. That is what? If the given elements are in ascending or descending order. Can you understand this? In this case, it goes to what? It goes to n square. Can you understand this? Okay. At this case only, space complexity is also go to the n. You may ask, why we are getting the space? We don't even use any auxiliary. We are using what? We are using a recursion. In recursion, it creates what? Internal stack. This internal stack also takes a space. Yes. So the space of this internal stack is log n if it is a distant average case, because it at most goes to what? Log n times only the depth. But if it goes for a worst time comes t, it will be what? O of n. Can you understand this? Like this example. It is what? Ascending or descending, it goes what? O of n. Can you understand this? Okay. To overcome this time complexity and make it efficient, we will use certain techniques, like we will use a randomized pivot. Randomized pivot. Picking a randomized pivot. This is the best solution. Or else, in sometimes, we will be doing a quick sort, but once it is known that it is a n square approach, then we will modify this what? A heap sort. Okay, but you don't want to understand these two, but still you can understand. if you want to know how to reduce the time cost, right? So this is all about a quick sort algorithm. So your job is to just rerun this algorithm by using my code. Just rerun this algorithm by yourself only, so that you can understand whatever I am done here. Okay. Now let us see the code in the compiler. See here, this is the code. Here I used one pivot partition technique. This is what? This is a forward pointer technique. See here, as it is, whatever I done there, I just put here equal. Okay, I put here. Let me submit it or run it. This here in a sorted order. This came in a sorted order, right? Okay. And this is the next partition function. This is a towards pointer technique. In this towards pointer technique, I return the same code I explained down. Okay. And let me run it. Here, it is also giving a sorted order of array. Hope you understand this. Thank you.